Welcome back to Learning with Merit. Today we're going to talk about routers and all of the different things we can do with our routers in our own home networks to improve our lives and really manage what we're dealing with. And there's a lot of information here, and it can be really confusing, especially if you don't know anything about networking on how do I actually manage my own router and deal with all of these issues. And there's a lot of things that you'll never actually use on a router. You could, but you may not ever actually use them. So the first thing we're going to look at here is how do I figure out how to access my router? And most routers will either have the information on the back, or you'll have been given some of this information by your internet service provider, whoever is providing that. But if you don't have either of those things and you're looking for how do I actually access it, the most likely thing is that you could do something like the ipfig command, config command. So, two ways. There's actually a lot of different ways to get here. But if you go down to your search bar, you have like a Windows machine, you go down to your search bar, you can actually type in CMD like that, and you will find the command prompt. And you want to click on that. I've got it big so you can see it here. And so I'm going to type in ipconfig like that. Now, there's a lot of gobbledygook going on in here with mine. That's because I've got a lot of different things. But you'll see VirtualBox, you don't need that. You can ignore that. We have adapter Bluetooth network connection, we don't need that. Tailscale, we don't need that. And then this is our first Ethernet adapter, we don't need that. We need this one that actually has my default gateway, and this is where my actual connection is at. So if you're on like a school computer where everything's plugged into a switch, you're looking for Ethernet adapter. If you're on like a device that's connected via Wi-Fi, you'll see one that says Wi-Fi adapter on there. Since this is my desktop is not connected to Wi-Fi. It's connected via Ethernet to my router, and that's how I get my internet connection. So if we look at this, some important things. Here is the IP address, the version 4 IP address of my desktop. This is private, so it's not public out there for anybody to see. This is in the private address ranges. Here's the private IP address in version 6, and then we have the default gateway. In this case, the default gateway, and for most of you, the default gateway will be your router. So we have an IP version 6 address on top, and then we have the IP version 4 address on the bottom. And we're going to grab that IP version 4 address of our default gateway. So I'll copy that address, and we're going to come over here, and I'm going to go to an address bar and paste that. You'll see whenever I do that, it takes me to the login page for my router. Now we're not going to log into my router and look through all my settings and all that sort of stuff, but the point is that I was able to find my router using that IP address. And that's what computers use. You could, if you know the IP address of a given website, you can just use that. You don't have to type in www.whatever, right? The IP address is actually the important part, and that's where DNS comes in. So if we type in www.google.com, it goes and performs a domain name service lookup, and it looks up the IP address of www.google.com, and then it uses that to actually send you to Google. So that's how you can find your router in most cases. So now I'm going to go ahead and I'm going to exit out of that. I've got a emulator here for my type of router. I've also got a few other routers we're going to look through. TP-Link, Asus, and Netgear are three of the most common and popular routers. I forget the name, but anyway, router brands. There we go. Router brands that you'll see. So let's look at this. So here we have internet status for a TP-Link router. Its connection type is a static IP, meaning a non-changing IP. Its IP address is always going to be the same. And in this particular case, the internet IP address is what we think of as a public IP address. It's 0.0.0.0 for this one because of the fact this is just like an emulator. It's not actually connected out to the internet. So here you would see your internet IP address if you have a TP-Link router similar to mine. Then we have the wide area network MAC address. This should be the MAC address of your router. If we click on the router here, you'll see we have some information like the device name, its IP version 4 and version 6 local area network IP addresses, which means private IP addresses, its actual MAC address right there. You'll see the two wireless frequencies. We have 2.4 and 5 gigahertz. You can enable, disable those. You have an SSID for both of those, so you can have a separate SSID for your 2.4 or 5 gigahertz bands. Both of them will have a password that you may need, and then we're going to ignore channel for right now. But channel is basically different bands for that frequency that you're going to connect to. Our guest network, so a guest network is if like I don't want people who come into my house or come into my business to use the main private sort of network. I want them to use a separate one so I can keep them from like messing around with my stuff. And that's what a guest network is for. So you can set up a guest network, and you've probably even seen these used. If you go to like a business or something, you'll see that it's, you know, whatever guest, just like you do here. This is TP-Link guest, TP-Link guest. That's what's going on there. They're using guest networks. And so I can enable the 5 gigahertz wireless guest network. Now, Ethernet status down here. Ethernet is going to be our wired connections. So we're using Ethernet cables, and we have the internet connection here. So this port is connected out to, if you're using copper, so you have digital subscriber line, DSL, copper, you're going to connect to that, and that would be the modem. Otherwise, you have something called an optical network terminal, which is for fiber optic cable. And the big difference is the modem is going to convert the types of signals that we send over electrical lines to the types of signals we want to use inside of like our router. And then the optical network terminal, the ONT, is going to convert light, which is what we're sending over the cables, and converts it to electrical signals and back and forth. 100 Mbps, that is a speed, so megabits per second. That's about as fast as this little connection can go. And then we have half duplex, meaning it's a one-way connection. So it's just one way at a time. It can either be going out or it can be coming in, but it can't be doing both. Then we have LAN here. So we have LAN 1, 2, 3, 4. LAN 1, 2, and 4 are not connected. LAN 3 does have something connected to it. It's the 1000 megabits per second, and mega is 10 to the 6th power, so one with 6 zeros behind it. That's how many megabits per 1000 of those megabits per second. And it's full duplex, meaning that it can go in both directions. So we can be uploading and downloading information at the same time. Mesh devices, this is sort of like if you're in a large area. So if you have a really big home, or you have issues with internet connection in different parts of your home, maybe because it's too big, usually that's the issue. Sometimes it's because the wireless connection has difficulty going through walls and things like that. You can use a mesh device, and these mesh devices are meant to extend the range of your network and sort of as seamlessly as possible. A great example of this is if you've ever worked in a business where you have pretty much the same internet connection over a very large area, they're probably using some sort of mesh. Same thing in like a school, for example. So you may notice in like every room of the school, they have something that looks like a router. Most people will call it the magical Wi-Fi box because they don't know what it is, but it is sort of like a router, and you can call it an access point or a node for the network, and it allows you to connect to it, but you're still connecting to the same network, and the router is handling all of that traffic. So in this case, we have MAC address there, IP address there. We have a location for this device, but this is basically a separate router, and they say it's in the bedroom and it has 0 clients. Clients are all of the things connected to it. And then it gives you a connection type. In this case, it's a Ethernet connection, and that's what that symbol is meant to represent. This one right here in the middle is not connected to anything, but again, it still has a MAC, IP, and some clients, but those clients are probably from the last time it was online because it's offline. Then we've got this one right here. Again, MAC address, IP address, location, and it has 5 clients connected to it, and its connection is Ethernet cable. So anyway, you can set up a mesh network in your home if you want to, and that's what this is for. Then we have clients. These clients are all connected to your router, the Archer A8 here, and there's some good information. So you should be able to see, for example, the MAC address, the IP address of the devices, and then what type of connection they have. So LAN is going to be an Ethernet connection. Then we have 2.4 and 5 gigahertz connections that you can see. You'll see some of these are offline. Then we have a real-time data rate. So these may be jumping around whenever you're looking at your actual network because the data rate that they have may be changing constantly. The idea is this is how fast they're uploading with an up arrow, downloading with a down arrow. Kilobits per second, kbps. Kilo is 10 to the third power, so one with 3 zeros, or 1,000 bits per second. So you take this number, multiply it by 1,000, and that would be how many bits per second. So lots of information, very fast with this network. There's also speed limit down here. So duration is just for how long. Speed limit is you can actually set sort of a throttle for these devices. And you can say, okay, you're only allowed to go this fast, use this much of my bandwidth. And think of it like this. There's only so much internet, that you can get through a wire at one particular time, right? There's only so much information you can send and receive at the same time on a given wire. And so what you can do is you can sort of partition it. You can set aside, this is as much as you get, this is as much as you get. And it will help free up internet connection for some of the devices, like like if you really want your TV to work, right, and be able to watch TV on it, you may give it more and limit all the other devices how fast they can go, and subsequently how much bandwidth they can take up. But anyway, there's only 6 clients on here. You may see different things, like if you look at this, you may see like your name and iPhone if you have an iPhone, for example. So there's always some name. You also may see several unknowns on here because they just don't have names to them yet. And I recommend, if you see unknowns, that you figure out what they are and name them so that you can keep track of them a little easier. We can look at internet here. So this is the type of connection that we're dealing with. Static IP, again, means unchanging. And basically, you set this information up, right? And it has an issue with 000 because you can't use 000. But anyway, most of you won't have a static IP. So you're going to want to have it on something else. You're probably in dynamic IP, which is exactly what you want. So dynamic means that you're going to receive a IP address from the dynamic host configuration protocol from your internet service provider, and that way it changes every so often, and that's actually a good thing. You don't want your public IP address to always be the same unless you're serving up like a web page or you're hosting something that you want other people to get access to. These other 3 on here that look like alphabet soup, you can pretty much just ignore. They're not going to be a big issue for most people. Triple PoE, that is going to be, let me think for a second, point-to-point protocol over Ethernet. And so this is, point-to-point is literally from one device directly to another. And that's not really what we're looking for on this device. You also have L2TP, which is layer 2 tunneling protocol. This usually has to do, usually is associated with PPTP down here. And it is used for virtual private networks, or VPNs. Most of the time you don't need this either. PPTP is point-to-point tunneling protocol, and it's been around since like Windows 95, so it's been around a really long time, and there's some security vulnerabilities with it, so most people don't use it. So these 3 you can pretty much ignore. Dynamic IP is probably what you want. MAC clone is to sort of spoof the MAC address of your router. There's really no reason to do that unless you have a reason, and if you have a reason, you probably don't need me to explain it. So we can look at wireless now. So wireless settings, personalized wireless settings that you need. So a lot of devices will come with their own special little types of tools and connections that go with them, and this is one of those things for TP-Link. This is Smart Connect. And basically what it does is it allows you to seamlessly go back and forth between the 2 frequency ranges that you have, so 2.4 and 5 gigahertz network ranges. And so it smartly meaning using a program, determines whether or not your device should use the 2.4 or the 5 gigahertz networks at a given time. There's really no reason not to just hit enable on that. That's not a big issue. But if you're wanting to mess around with these, you have the 2.4 gigahertz frequency range. You can give it its own SSID, so name. You can hide it. Hiding is good if you don't want other people to be able to connect to your network or see that your network is there. And so it's never a bad idea to do that, especially if you know the name of your network. You can hide that. It's really good if you live in like an apartment complex and you don't want other people to connect to your network without your permission. And you don't even want them to know that it's there. So you set up your network's name and then you hide the SSID and nobody else can see that your network's there. Now that's not foolproof. There are ways to figure out your network is there, but most people aren't going to be able to figure out that it's there if you hide it. All right, more alphabet soup. So security, and this is a big one that people are always worried about, like which one am I supposed to pick? So on older devices, you'll see something called WEP, which is Wired Equivalent Privacy. And that's old. Pretty much just don't use it at this point. It's old, it has security vulnerabilities that we know about, and so don't use that. WPA2 that you see here. WPA2 is going to be Wi-Fi Protected Access, version 2, obviously. And then you'll see WPA3. If you know anything about numbers, you know that WPA3 is probably newer than WPA2, and so we're going to look at those because they're going to be a little bit better. And then you have enterprise down here. Anytime you see the word enterprise in computing, it means business, right? So some sort of large business or something like that is going to be using the enterprise type technology. Now that doesn't mean that you can't use it. It just means that it's not necessarily designed for home networks, right? And that's why they have personal down here. So your best bet is either of the WPA3 options. So either W3 personal or W3 personal plus WP2. I'm just going to go with this one here. The rest of this alphabet soup is pretty simple. PSK stands for pre-shared key, which has to do with cryptography and how the stuff is encrypted. AES is the standard they're going to use. It's the Advanced Encryption Standard developed by the U.S. military. And this is the one that we pretty much use today is AES for most things. Again, pre-shared key here, but TKIP, that's Temporal Key Integrity Protocol and is old. We mostly don't use it anymore. So you're wanting to look for, you want most advanced security here, you're looking for WPA3 and you're looking for WPA2 with a pre-shared key and Advanced Encryption Standard if you're going to use that. And that's pretty much all that stuff is. The PSK and AES is about how it's encrypted, and you can look up more about that if you're interested. A lot of math that goes into those encryption standards. Of course, you have a password. You can enable the 5 gigahertz if you want. Give it a name, its own security. Again, you're looking for whatever pretty much the most advanced is most of the time. And then you give it a password. You can enable this for the guest network, hide the SSIDs or leave them open. If you have a guest network, you probably want to leave the SSID open, right? But you could selectively turn it on if you like no guests are coming and you want them to be able to use it. All right, advanced stuff. So operation mode, you can use this particular router as an access point or a node in a larger network, and that's like the mesh stuff that we were talking about earlier. So you use these in order to make your Wi-Fi area, right, your wireless connection area larger. And whenever you do that, it still allows it to connect out to the internet and all basically be a part of the same network. And so you can use this as an access point, or you can use it sort of like a node in a larger network. And the difference between an access point and node, access point, and you'll hear most people call it an access point, whether it's a node or not, but an access point is another place where you can connect to the network, but is not necessarily seamless. So you may have to reconnect to it every time you can get close to it. A node, however, is sort of, it tries to be seamless, so you don't have to disconnect and reconnect as you go from one point to another. You just automatically connect, and you don't have to worry about it. Most of you aren't going to have a mesh network or need an access point unless you have just bad internet through the walls or something, and so you're going to leave it on router mode. We look at our network, we got some information here, so we have our status, so that gives us our connection type, which is probably dynamic IP for a lot of you. You'll see your IP address, your default gateway for that. Default gateway is going to be, so default gateway can be more than the router, but in most cases it is your router whenever you're dealing with a home network. And so this may be like where your router automatically connects to if it's sending a signal. We have DNS for domain name service, and that's how we're going to translate those URLs like www.google.com into IP addresses, and usually have a primary and secondary, so one you usually use and then a backup. Local area network information, so this is the MAC address of your router, this is the private IP address of your router, and then the subnet mask, which we're going to ignore for now. You learn more about networking, you can learn more about the subnet mask as well. DHCP server, so this is talking about the one for your home network, and this is going to assign IP addresses from this pool of IP addresses to new devices on the network or current devices on the network. And this tells you that it's enabled, and of course you can disable it if you want to, give everything a static IP address, but most of you are just going to use the dynamic host configuration protocol. We have dynamic DNS. So we have a service provider. Most of your service providers are going to be your internet service provider, but you could change this to like Google's DNS if you wanted to. And it'll give you some information about that there. If we look at internet, we have static IP, and this is where we need to set everything. Then this right here you haven't seen. MTU stands for maximum transmission unit, and this is the largest like size of a packet of data. So when we send information across the internet, we send it as packets, right? And instead of sending the whole thing at once, which would be a real problem for internet transmission, what we do is we send it broken up into smaller pieces, and then on the other side, once we receive all the pieces, we put it back together. And that may not make much sense to you right now, but in general, that's what we do. And it makes it a little bit easier. The default, and pretty much everyone uses this, for maximum transmission unit size is 1500 bytes. So that's as large as the packet will be, and you'll see those packets sent out and assembled over the internet. And we could look more into this, of course, if we had like a networking course, but right now we're just trying to teach you the basics. You probably don't want to change that. I would just leave that by default. If you want to change it, you probably know enough to change it, and you don't need me. If we do dynamic DNS, it sets up most of this stuff for us, and our dynamic IP, I mean. And then we have renew and release. Renew is sort of like update my stuff, refresh kind of. And then release is give me a new one. So I want a new IP address, I want new information, all that sort of stuff. And that's not a bad thing to do occasionally. MAC clone, we already talked about that. We have network address translation, or NAT, enable the NAT. This is like if we want a device to be able to connect, like if we have a device try to connect to our router using the public IP address, it will send it to the right device. So it translates from that public IP address to a private IP address and allows you to connect to that. This is a good example of this is you have a computer that's hosting a website and you want other people to get to that website, you might use something like this. And then we have internet port negotiation speed setting. Basically what we see is different speeds here. 1000 megabits per second is going to be the fastest, 10 megabits per second is going to be slower, and then full duplex meaning both directions, upload and download at the same time, half duplex meaning upload or download not at the same time. You can do one or the other. If we look at local area network here, we can look at some of our connection settings. Again, there's the router. Interestingly, you may notice that that is the same address as my router. We're not on my router right now. A lot of you will probably have this address as your router's address. Okay, it's sort of it's not exactly reserved, but it's close enough to reserved that it might as well be. You may also have 192.168.1.1. You might have 192.168.0.254. These are all common addresses for routers, so you might try those if you're having trouble with the IP config command. Of course, MAC address there, subnet mask, we're going to ignore. IPTV, VLAN, so IPTV is for Internet Protocol TV, and then we have virtual local area network settings. Most of the time you want to just leave this on default depending on what you're dealing with. Multicast is good for things like trying to simplify how fast certain connections are. So let's say, for example, you need to send out information to multiple places, and it's always the same information. Multicast can make that a little bit faster. Rather than having to send it individually, you can send it as sort of a group. It's like the difference between a group text and just texting each person individually. And that's sort of the difference there. It's not exact, but it's close enough that it should be a good analogy. IGMP, that is a protocol. It's called Internet Group Management Protocol, and it usually goes with the multicast, and it's used to create the groups, so the group memberships. Snooping and proxy, if you're going to use this multicast stuff, you should probably just leave this stuff on default. A proxy you can always think of as like a middleman. So instead of you, it's someone acting on your behalf, right? And so you could have another computer acting on your behalf. And we use proxies for things like hiding our IP address and stuff like that. Of course, you can pick the version. Usually the most recent version is the best idea, unless you know what you're doing. DHCP. So this sets up our server for passing out the IP addresses. So you enable it. Most of you are going to enable it because I doubt you're going to set all this by hand. You can set the pool of addresses that you want to give it. Usually it's a good idea to just leave them as default unless you have a specific reason why you need to. There is a specific amount of time that that IP address is held by a given device. Most of the time it will reassign the same address because it's just easier to do that. It'll reassign the same address for a device. But if you disconnected a device and then added a new one, you would see that it may reassign the IP address you had. And so that's what's going on here. You, of course, can increase the amount of time that that's done, or you can change it with some other things down here. Default gateway, primary and secondary DNS. Remember, this is how we get our domain name stuff, and then we have the default gateway, which is where we default to connect to. Most of the time, in your home network, this is your router, like I've said before. Address reservation is really good if you want a specific device to always have the same IP address, and so we set that IP address aside. There are good reasons to do this. Most of the time on your home network, there is no reason that you would need to do this, unless, of course, you sort of know what you're doing, right? You're trying to keep a certain address always the same, so you're always connecting to that device in a certain way. This is sort of like best of both worlds. You can have DHCP where it, automatically gives stuff, but also sort of have a static IP address for a given device. Anyway, I do use this on my home network. There are a few devices I want to always have the same address, and so everything works correctly, and so I'll use that address reservation. Here's the client list, so these are all the devices using the dynamic host configuration protocol. And of course, you can refresh it and see it, how long they've had that IP address, what their current one is, and what the MAC address is. And this is why MAC addresses are so important. MAC addresses allow us to individually identify the device. Where the IP address may change, the MAC address will not. Unless, of course, somebody's trying to lie and spoof their MAC address. That's why it's so important to have those MAC addresses and those IP addresses. Dynamic DNS, this is going to be typically provided by your internet service provider, but you could also set up your own DNS. So like if you wanted to use Google's public DNS servers instead of what your ISP is providing you could do that. Routing, so determine a prefixed route for network packets to reach a specific host or network. Most of you guys are going to leave this on whatever the default is, but you could specify where you want that traffic to go. So you see default gateway here, in this case, is not necessarily a router, but it's a specific place you want traffic to go if the destination is one of these devices, right? And so that's just something to think about for the future, but you can specify where you want the traffic to go. And that's what traffic really is. It's packets of data. And then we have something called a routing table. The routing table, the simplest explanation of that is it is there to keep track of all the different devices. So we need a way to keep track of where is this device at and where should I send the information that's supposed to go to that device. So for example, a routing table will often have the MAC address associated with a given IP address. And so this is to keep track of all the different devices. And if you clear this, all those devices have to communicate with each other again in order to make this table. Without this table, the network would be a lot slower. You need it to be fast, and so it needs this information, and it needs to be easy for it to look up. TP-Link ID is something specific to TP-Link. Easy Mesh is there'll usually be some sort of specific thing like this with most routers, but we're just going to gloss over that for now. Remember, we talked about what a mesh is and what it's for. Wireless settings, we can look at these. Of course, we've already seen some of those wireless settings there. Transmit power, this is basically going to determine like how far your network information, your network signal will go. And so like if you want the widest area, you want your transmit power to be high, but of course that uses more electricity. Channel width, we're mostly going to ignore that, but it indicates how like basically the range of frequencies that a given channel can use. And then there are some different channels here. We're not going to talk about channels, that's more advanced networking. And then we have mode, and you'll see that 802.11, we've talked about that before. 802.11, we've got N, GN, BGN. These are different pieces of the 802.11 standard for wireless communication. Most of the time, just leave it at the default unless you know what you're doing, meaning you've done a little bit of research into what you may actually need. There are differences between these, but just leave it on what its default is unless you know what you're trying to do. Same thing here, transmit power, channel width, channel. Most of those you're just going to leave to auto. That's the best thing to do in my opinion. And we've got mode. And then MU and NEMO. You can copy that, go right over here to Google. Let's see what that stands for. Go to your network world. It goes multi-user, multi-input, multi-output. Okay. My suggestion on stuff like this, just leave it at whatever its default is. That's not a bad idea. Just leave it enabled. More guest network stuff. Guest permissions. Allow guests to see each other. Allow guests to access your local network. In general, I recommend you leave those off. Okay? The whole point of a guest network is to provide as little as possible to the guests while also giving them internet connection. This is a security feature. So don't ruin the security feature by turning on all the stuff that ruins it. All right. Wireless schedule. So this can schedule when you want your wireless network to be on and off. So like, for example, if your wireless goes down in the middle of the night every night on purpose, that's sort of what has been set up here. It's really good. People will use them for like parental controls, for example, to prevent you from playing on the internet all night. Wi-Fi protected setup. So this is, you've probably seen ways to connect to your devices by pushing a button on your router. So you can go and push a button on your router, and that will allow a device to connect very easily. That's what this is, and it's meant to be a easy tool. In general, it's a little bit of a security hazard because anyone who has access to your network, physical access, could attach their device without much work. Right? So usually you want to turn this on, use it, turn it off. That's usually what this is for. We've got some additional settings here. Lots of stuff going on. So we've got WMM, short UI, AP isolation, airtime fairness. These sorts of things are sort of, if you know what you're doing, you may want to come and mess around with them. But in general, just leave them as what their default is. All right, so WDS. So what WDS is it's basically it's used for your access points. So it's called wireless distribution system, and it allows us to connect those multiple access points together sort of in a standardized way, and then you can use WDS bridging here to use it without a wire. And so it sort of seamlessly connects all of your different access points together or nodes together so that you have sort of this one simple network. So this is really only if you're using really only if you're using those access points. NAT forwarding, we have something called port forwarding. So there are different ports, and they have numbers, and you can think of these as like places to access. So like doors you can go into and out of in the device, and they're not physical, but they are basically numbers associated with different services and things like that. So port forwarding allows us, if somebody's trying to access a given port, it goes to a particular spot. Most of you do not need this, and you should probably just leave it off, right? So you want to turn that off and not use it. Otherwise, you may have a security issue. Port triggering allows devices on your network to selectively open and close ports. Most of the time, you don't need this. There are some cases in which you might. UPnP is Universal Plug and Play. This sounds like a really good idea. It's not always. But it's designed to make it so that you can open ports and things like that to make your gaming and TV and all that stuff more seamless and easy and have good, fast connections. And we have something called a DMZ, which is a demilitarized zone. And this is interesting because it comes from other ways of thinking about stuff. But a DMZ has to do with, it's sort of like you want to separate part of the network out so that there's a protection zone. So like you have some important private information on some devices over here, but you want to allow certain devices connected out to the internet. And so, for example, you might put like your gaming and your TV in a DMZ, and then your personal computer that may have like bank account information on it and passwords and stuff like that, you may want to put that outside the DMZ. And so the DMZ is really there to protect you from those internet connections. And you sort of want to have unfettered access to the internet with those other devices, where maybe you want to have some better security with the stuff that has your protected stuff. There's parental controls. I'm not going to go over all the parental controls because if you're a parent, you probably don't want me to do that. Global settings. So here we have something called QoS. That's for quality of service. And this is designed, it literally is what it sounds like. Quality of service is to try to improve the quality of your internet connection. And what it does is it prioritizes network traffic between the internet and certain devices. So like if you want to enable this, you could say like, okay, you know, this device is my Xbox, and I want my Xbox to have the best internet connection possible so that I can play my games. And so you can change some of these things. Bandwidth is basically how much of the internet connection you can use, right? So it's like everything is using the same band. We give a certain amount of width for this device, certain amount of width for this device, so on and so forth. So you want to increase the amount of bandwidth for certain devices, like maybe your Xbox, and decrease it for other devices that you don't want to have it. Now the problem is, you need to be careful about how you do this because you may make it so hard for some devices to work because you've given them such little bandwidth. They're going to be really slow. Okay? But if you change this, you can effectively increase the experience that you have on certain devices like gaming systems, because it prioritizes their connection. Security. Let's talk about a firewall. So firewall, different firewalls here. So a couple of things that in general are good security practices. A firewall is basically a program that's designed to filter traffic. That's what it's designed to do. It prevents some traffic from coming in, other traffic from going out, and it's all based on a set of rules. But it's designed to protect you from connections. We don't want to just allow whatever connection from wherever, however, right? So we use a firewall to check that attempted connection and prevent it. So for example, if we look at the SPI firewall here, and of course some of this says unavailable when NAT is disabled. Your NAT should probably be on, and then we are going to mess around with this. So SPI firewall is, SPI stands for Stateful Packet Inspection, And basically what it is it's checking whether or not the packets that are coming in and out of your network, if they're associated with a current connection, right? And so it helps filter out some of that traffic that maybe you really don't want. In general, you see where it says respond to pings from the LAN, respond to pings from the WAN. The LAN is your local area network. I recommend you leave the pings for that on, but you disable the pings from the wide area network. And the reason is you don't want somebody from outside of your network checking to see if your router's there with pings. And you usually want to try to hide as much as you can from the outside world. So I recommend you leave that off unless you have a specific reason why you need it to be off. This one I'd turn on, but of course one of the settings that's on this emulator won't let you turn it on right now. So we're just going to leave that as it is. Access control. So we have something called blacklist and something called whitelist. Now here's the difference. You'll also see these called deny list and allow list these days. So they sort of have both names. Blacklist is all of the devices you want to deny access to your network, and you can specify these devices and tell them, hey, I don't want this device. You know, you can click add. You can go and pick a device and say, I don't want that one. Boom. And I've added that device, and now it's prevented from accessing my network. Whitelist is sort of the opposite. I want to deny everything but these devices. So blacklist is specify what you want to block. Whitelist is specify what you want to allow, and everything else is blocked. And so there's good reasons to use both of those. In general, most people will just leave it on blacklist and only deny the stuff that they don't want. For the best security, my opinion is go and add all of the devices manually and then leave it on whitelist. And then it only allows those devices and nobody else can connect to it. The only downside to that is whitelist is a lot more work. You have to go in and add each device you want to allow onto the network. So a lot of people just leave it on blacklist because it's too difficult to go and do the other stuff. IP and MAC binding, this is, so basically we want to give a specific IP address to a specific MAC address, and this is to prevent a certain type of attack called ARP spoofing, which is basically, it acts like its MAC address is a particular, so, okay, let me say this in a better way. It lies about who it is. That's what it is. So if you bind the IP to a given MAC address, it prevents them from lying about who they are, right? Because those two, that MAC and that IP go together. And you can't say, I'm this IP address with a different MAC address, right? So it's sort of like one device lying and saying it's another device. Anyway, take a cybersecurity class, and you can learn more about that. Those are cool problems. Anyway, ARP is Address Resolution Protocol, and this is how we figure out who is at what address. So what MAC address is what IP address. That's what the Address Resolution Protocol is for. And this is sort of another table keeping track of the MAC addresses and IP addresses of the given devices so we know who is what. And then we can selectively bind those as we see fit. Most of these, so application layer gateway settings, most of these you want to leave as default. Just leave them. We've already talked about these first two, but pass-through basically allows the information to go through your router as encrypted traffic without the router having an issue with it for the most part. That's what pass-through is for. And then we have FTP, which is File Transfer Protocol. We have TFTP, which is Trivial File Transfer Protocol. RTSP, which is real-time, let's see, got to think about it for a second. Real-time streaming protocol. So this is like if you have a camera, like you have a security camera, RTSP is probably what it's using. And then H323 is a telecommunication standard, which is like for phone. And then SIP is going to be Session Initiation Protocol. Mostly just leave it default. don't worry too much about that one. Anyway, most of these, it says recommended, keep these as default. Most of these, unless you have a reason why you need to change them, you just leave them as the same. IP version 6, everything's starting to use IP version 6. You want it turned on if you can have it turned on. Right? Mostly I just leave it as router. For wide area network, you're probably going to have a tunnel 6 to 4, which means a IP version 6 to IP version 4 address for when it's an issue. And then we have all of these IP version 6 addresses for our different devices. Of course, we already talked about MAC clone. We already know what the LAN is and what these addresses are for. Last thing, we look at our system. There's a lot of stuff going on here. I'm not going to go through everything because it's not too crazy. Firmware, you need to keep up to date. Most people will just leave it on auto update. Administration stuff is setting the password. You should have a set password so people cannot log in just whenever they want. There's a log of information. This can be good, especially if you're experiencing an issue and you need somebody to look at it. Having that log will allow them to mess around with that. There's time and language for setting the time and the language and things like that. Rebooting it, this is a great way. Instead of unplugging it and plugging it back in, you can connect to it and reboot it this way, and it will help reset some of your internet issues if you have them. And then LED control is like, you don't want to see those lights at night. You can turn those off. So anyway, that's the basics for pretty much any router. All of these things, they may not be in the same place, but they will be on there. And real quickly, the last thing I'm going to do is I'm going to show you these other two routers. I'm not going to explain everything that's going on, but we're going to look at these other two router interfaces. They didn't like that I took my time on that. Alright, so here we have a simple router interface for a ASUS router, and there's a lot of stuff going on here. Here's a network map. It shows you, we see that PA2 personal. It's got a lot of information, but a lot of stuff that we've already talked about. Right? So we've got AES, the encryption there, pre-shared key, 5 gigahertz band, or frequency. This is our wide area network IP, which is our public IP. We have dynamic DNS, that's what DDNS is. Here we have the mesh stuff we were talking about. The guest network stuff we've talked about. We got some of this. This is a special thing that goes with this ASUS device. It's a certain type of protection. We're just going to go over that. Adaptive quality of service, so we can set what's using what, and we can see megabits up and down. We can see all of this sort of stuff, depending on what you're looking at. There's a little traffic analyzer to check your traffic. These are all just little gimmicky tools and stuff like that that's kind of cool to have and look through. Right? You can see what's being used for what. AI Cloud here. AI is their little fancy thing, and they've got some more specific stuff in there. Most of this you just leave it default because you're not looking to do anything fancy unless you know what you're looking for. You have those wireless settings again. Dual band, 2.4 gigahertz, 5 gigahertz. We're seeing there's our SSID. There's hide SSID. Used in the different protocols, Wi-Fi 6 mode, authentication method. Usually we want to do WPA3 if we can get away with it. AES encryption. Frames are what we call packets within a what we call the layer 2. So frames are data that also travel through a network, but they're not going to travel over the internet. Frames never go over the internet. They're always a small local type thing. Anyway, so we have channel bandwidth with our 2.4 and 5 gigahertz there. Local area network stuff, IP address, subnet mask. See, this is all stuff that we went over and looked at already. You're just seeing it in a little bit different format. Right? Universal plug and play, network address translation, connect to your DNS server, what type of authentication. Authentication is like, should somebody have to type in a password, for example. Host name, MAC address. TTL is time to live. Mostly just leave that as default. Has to do with how long the packets can exist inside of a network, bouncing around before they are just dropped. We have connection type here. So we have static IP, pass-through, tunnel 6 to 4, If you have IP version 6 turned on, you probably have something like 6 to 4 as what you're using. VPN stuff for virtual private networks. There's the firewall again that we talked about. Again, this is preventing traffic in and out that we don't want. That can be dangerous sometimes. Enable firewall. Yes, you want a firewall. Trust me, you want a firewall. DOS. So DOS is denial of service. So think of it like this. If I'm trying to toss you a ball, and I'm just tossing, let's say it's like a golf ball. So I'm tossing you a golf ball, and I'm just tossing you one at a time, very slow. You can probably catch it. But if I start sending like 16, then 20, then 30 at you, and I just keep sending them as fast as I can, you're probably not going to be able to catch them all. It's the same concept of a denial of service attack. So basically you send way more traffic than someone could handle, and that's what's going on with denial of service. So there's some protection of that. Basically, if it receives too much traffic from one particular device, it'll just block that device for a while. ICMP echo is what we use for ping requests. In general, we want to not do that for a WAN, right? Looked at that. More firewall stuff, more administration stuff. Talk about access point modes. A node. Talked about what a node was. Then we have our system log. And then some of them even have like these little network tools that will allow you to ping and test some stuff on your network. So anyway, basically the same thing on this router. And then this is a Netgear router. See if I can make this a little bit bigger. This one, the emulator for this one is not as great, but it does have some things on it as well. So if we look at this, you have the general information for basic. It'll give you your SSID. It may have your password right there. It'll tell you the number of attached devices. We can look at advanced, and it gives us more information. Again, you'll see we're using, we have DHCP, we have a MAC and IP address. Those are our domain name servers. Those are IP addresses we're using there. We have 2.4 and a 5 gigahertz band, or frequencies that we're using. Right? You have a guest network, which is currently turned off. AP is access point. Right? Broadcast name is, are we broadcasting the SSID for people to find? Right? Are we isolating it from the network, the other network? GUI is GUI. It means graphical user interface. That's sort of what we're looking at right now. Firmware, you want up to date. Hardware is not as easy to change, but it will tell you the hardware version. If we go to, there's the setup wizard for setting up everything. This is usually whenever you begin the device, you want to set it up for your network. Wi-Fi protective setup, we already talked about what that was. We have the same things. We have our internet setup. We get dynamic versus static, IP addresses, MAC addresses, domain name service here. So you're seeing, hopefully, you're recognizing most of this stuff is the same as stuff we've already talked about. See, there's WEP that I talked about earlier. Right? It's all here, all stuff that we've already talked about, and it shows up in all of the different routers. It just may be in a little bit of a different format. Remember, here's our security. Whoops. That's right. Let's see if it'll. So access control. There's our whitelist, blacklist, deny list, and allow list, whatever we're calling them these days. You'll see both. We got this, so you can block sites. You can use the router to block traffic and not allow people to go to certain websites. That's what they do to block stuff at school. There's a router level blocking that they use with Cisco, and that's why you can't seem to go anywhere that you want to go when you're at school, going to inappropriate stuff. Certain services you can block, that type of thing. You can schedule the Wi-Fi, or you can schedule when to block stuff, all kinds of things like that. So all stuff that we've seen before. So in every one of these, you may have different different formats that they show the information in, but all the information's there from everything that we've talked about. So yeah, I hope you learned a lot about your router and using your router and all the different things that you can do with it and how useful it can be. And thanks for watching.